System design in a hurry pattern, right? So there's the simple DB backed CRUD service. Like you will see this, I feel like all the time for something. You'll do client into API gateway, into load balancer, into service, into cache, into database. And then like they'll ask you about like scaling this out. So you'll have multiple services and then like multiple databases or whatever. Yeah, I mean, this is like a pretty simple, like if you have like something like upload YouTube videos or like upload files, like something like this, food review service, like, and this takes like it's so short to write out, but yeah, you'll see this a lot, I think, for system design interviews if you're mid-level for sure. Many designs start with a simple pattern and then you add complexities or whatever. So I would agree with that. This design is too simple for all but most junior roles. Also, I don't like that they say junior roles because what junior candidates are never asked to design systems like ever. So I don't even know like why is that even mentioned for junior roles anyways, but it's a good start. For all those, we recommend moving quickly in your interview solves so you can spend ample time. So pound it out to move to the next thing. Yeah, but you'll probably just be drawing this like for probably 90%. This is probably going to be the starting high level diagram, and then you'll talk about what database you want and how those databases interact, and then services, and maybe add more services or whatever. But depending on what you're trying to do, workers is like a thing too. Async jobs, common pattern, system design, process data. Popular is use SQS and then use a pool of EC2 or Lambda functions, guarantees delivery. So you have some queue workers into the database. Happens if you guys have seen web crawler. This happens in web crawler where you have like some, I guess, URL frontier, and then you have like a list of machines that are like scraping, and then they're like storing the URLs or the content of the URLs into like some other location. Yeah, you'll see that for that, and I'm sure I want to say too ad clicker maybe uses workers. So like for batch processing and using like MapReduce, what you do is you take like a massive collection of events. So if we have like, oh well, this ad was clicked, like I don't know, ad one was clicked like 1,000 times, and ad two was clicked like 5, but you just keep going to all the way out to like add like 1 million or whatever, which is a real thing. Like Facebook has a ton of ads across like 7 billion people in the world or whatever, but has like this, but you have all these orders, but you don't know what they are. So you can do this like merge sort type algorithm where you just break them up into groups, and then you like sort those individual groups, and then like once they're built, you get like the winners, like top 3 winners, and then you go through and get like top 3 winners out of those or whatever, and keep going down until you're left with like the actual winners. That was map reduced in like 5 seconds, but workers are the things that do that. That is a just this pattern. You have like some queue of data that you need, pass it into workers, and then they do some work. That's the pattern. Two-stage architecture is a scaling binary 64. What is up? So two-stage architecture. A common problem in system design is in scaling an algorithm with poor performance characteristics. Consider trying to find two images that look about the same. There are many available algorithms that can compare images and give you a score, but these are wholly inappropriate. Then you compare large number. What can we do? Use two-stage architecture. We use a fast algorithm to filter out the mid, and the second stage use a slower one for the remaining one. Interesting. I haven't seen this really at all. Fast but inaccurate, and then you filter. Yeah, I haven't really seen this. That said, I probably haven't looked at recommendation systems. I haven't actually looked at recommendation systems. I also haven't looked at search engines, but makes like the idea makes sense. Route planning. Again, I don't know anything about this stuff, but okay, sure. I mean, I can get behind the idea of like start wide, just narrow down and kill like for the things that obviously aren't, and then you go in and refine it. Event-driven architecture. I don't really understand this. Like it's called event-driven, which I guess is like producers, routers, and consumers. But I don't really know any like where they what this even is really. I mean, it just feels like it's just servers talk to each other is what is, or like message queues. Like this feels like just describing a message queue, but okay. But it does have a name, and I know that this is like a thing that's tossed around. Event producers generate a stream of events which are sent to a router. The router dispatches them into the consumers. Yeah, right. Producer consumer. That comes up like a lot. Is how to handle failures. So Kafka is durable. It can pick up where they left off. This can be a double-edged sword. If you only process n messages per second, you may quickly find yourself in a situation where it takes hours or days to catch up. An example of EDA is an e-commerce system where events are emitted every time a new order is placed. Yeah, this feels like the server, what is it, server sent events? Really just anything though. I mean, this feels like it's probably in like most things, very similar to this thing here, where you just have like some triggers that are set up. Like once something gets added into a database, like this could be if it's like a messaging system, like Facebook Messenger. Once something gets added into the database, you want to notify all the users that they have a new message. So you end up having like this producer consumer type thing going on. Or even in here where if something is new as added, then it pushes it into like one of the workers and then they go. Then durable job processing. Need to manage long running jobs that can take hours or days. Would you just split this up? Competitors use Kafka log to store the jobs and have a pool of workers process them. They can periodically check their process or check their logs and see, and then you can pick up where another one left off. Interesting. More difficult to evolve with time. If you change a job, you'd have to handle the old and new formats for a while. Then you get proximity service. This is like huge. Like this is like a big pattern, and it doesn't feel like it feels like they're not like that different. But you can use Postgres, has like allows locations, and so does Redis. So you can use latitude and longitude and all that. But anyways, those are the patterns that he mentions here. I think these are like all fair and common. There's yeah, regarding API requests, I mean, they're always going to fail actually in a distributed system. You're always going to have like that case. Like it doesn't even matter if they're doing two things at once. I don't really know if, so like you send something to an API, is that what you're saying? And then it needs to send it to this one or something. And then you're saying like, what if the second one fails and then the first one? I don't really understand that idea, but they will always fail, especially if you have server 1 pointing to server 2. You're in a distributed system with tons of requests. Eventually a network is going to fail. Eventually it's going to fail. And then you don't get the data. So that's the problem. So typically how you fix that is you send it into a message queue. And then I'm guessing it has like some kind of acknowledgement that can say if it's done and you can retry. That'd be my guess. But you send it into like some kind of message queue and this will store it forever. It's like a little database. And then you can grab it from here, grab it from the message thing or whatever. But that's the change data capture. So this allows you to copy data like super, super well, which is generally something you want to do. And with Kafka, you have like a little just log and it just like writes all the things that have been done or whatever. So that if something fails, you can just go right back up to the top and read off of it if the message queue. That's how that message queue is kind of implemented. But anyways, I guess this was essentially the his patterns, the hello interview patterns. Overall, again, there's way more patterns than what's mislit here. It sucks that this is a good resource. I think it's a good start, but it's not going to take you there. I'm going to go over this DynamoDB for hello interview and give my thoughts, opinions. I actually think this deep dive section is really good for them because they taught me a lot of stuff I didn't even know about these technologies. I didn't know Redis could actually hold geolocation data. Maybe I've seen it before, but I never actually seen it used or even talked about. DynamoDB, I've used it a good amount, but there's some things that I didn't understand about it. And then Elasticsearch too, this was really huge actually, because I didn't understand Elasticsearch really that well. I understood it, but I didn't know how you would actually use it. And actually, why not? Why don't we just go into how do you actually use it? Because I think this is actually kind of interesting. I think it's interesting because Elasticsearch is I've seen it used for handling search for a lot of applications like Twitter, Facebook. I don't know. I mean, just in the system designs, I don't know if the companies are actually using it. They probably are though. And I understood that it was an inverted tree, but I didn't know you can improve search history and filtering using it or how it would work. And so essentially what you have is, I guess I'm gonna draw this out actually. So the idea of an inverted tree is that if you have something like you have the cat and the dog or something, and you have some other documents, cats, love hats or something. I don't know. What you can do is you can actually separate these and you can say, oh, well, document 1, or sorry, cat. We see cat in the name document 1, and we also see it in document 2. So if you want to do a search query and find out where all the cats are, you already know the documents that they are. They're these two. This is called an inverted tree, and it's the basis of it. What I didn't understand is that, okay, so you have these documents, right, which is just JSON data, really. You can store anything. You don't have to store that one string. You could, keep more details on it. And then you're going to have an index. I actually don't know what an index is. I guess it's used for searching. I actually don't know. An index is a collection of documents. Each document is associated with a unique ID. So it's like a database table of these documents. Mappings and fields. So then you have to tell it what fields do you want to map onto. So you have these documents, but you want to know what are the searchable entries, and so you just define those into Elasticsearch and say, oh, well, okay, we're going to be able to search on title and author. So you create these little mappings that will allow you to search on them, and then you just start creating them. So then you can start putting them inside. I guess you can declare the number of shards and replicas that you want. So for scalability, can increase these, and then set the mapping for all the fields that are going to be searchable, and then you just add them. So you can do like a post request and add a document and just add more documents and so on. And then once you have like everything's inside the database, which is like, Elasticsearch database or whatever, you can just start querying them, which is just like a search query. But it's super cool. I didn't, realize like it was kind of broken down like this. Now that said, I'll probably never use this in an interview, but maybe I will. I don't know. And then architecture, data nodes. I actually don't know. We're not going to go over any of this stuff, but yeah, good for read heavy. It's not a relational database. Not all search problems require it. If your search is small, then you can just query against your primary data store. It's really good for massive amounts of data, seems like. That's Elasticsearch. DynamoDB, I again want to talk about DynamoDB just because it's used the most. I feel like and there's probably like one, DynamoDB and Cassandra and no like SQL, Postgres, or whatever are probably in a ton of applications. I feel like NoSQL just isn't used that much, but you'll hear this word a lot thrown around in like any system design, like textbook and things. It really feels like it's powering like a lot of powerful applications. Why is it nice? It scales completely. Like you don't have to do anything. All you have to do is like click start on the database, and then it just scales massively. Pass in more and more and more and more data, and it just scales. Again, fully managed. So again, you don't have to pay a software engineer $100,000 a year to like play around with like a wonky database or like fix things or update things. It's just all done by AWS. And it's key value store, so you can literally store like ID1 and then just store as much data as you want into it. But I think there's a limit. I think it's, obviously for any database there's a limit, but for all these it's like really, really nice, super nice. So there's like tables, items, attributes. A table is just like the collection of like the data that's storing it, right? It's very similar to SQL. And then the items are, I guess, each of these things, right? Each entry. So maybe like an item is like a row in a database. You could consider that if you're used to relational databases. And then you have attributes, which are like the columns of the data: first name, last name, age, state. And they can be null. You can have null entries, whatever. These are just like the language of DynamoDB. And then you would just go to like your AWS page, enter a table. Like it literally takes 5 seconds to do. Enter your partition key. The partition key is going to be what's indexable. The key value store, right? Key values, just like a hash map. And then you can have a sorting key if you want to optimize your sorts even more. If you know you're going to be getting data like somebody's date, you can just sort on the date and it'll be faster for your filters. When combined with a composite primary key, sort keys used to get items with the same partition key, enabling efficient range queries. So you get nice range queries. You can create a primary key with a partition and sort key. So DynamoDB uses consistent hashing and B trees under the hood. And then you get secondary indexes. I actually don't know too much about this actually, but GSI, an index partition key with optional sort key, that's different. So you can query based off other ones and it would be faster. And then you have local, but a different sort key. You just change them in the AWS console. You could have a chat table with messages. You were probably going to want your primary partition, right, to be the chat ID with sort on timestamp. This way you can easily get messages sorted by time. But then what do you want to show users all the messages they've sent across all chats? So then you need another one for their user ID with also one timestamp. And then GSI is accessing data, scan operation, and query operation. Reads every item, returns a result, and paginated response. And then query operations. Scans, read everything, but you want to avoid it if you have a large data set. Query is query based off the primary. And Dynamo does not have a structured query language. You just use the AWS SDK. So in here you just say the condition, key condition. Pretty weird. Pricing model. Yeah, just super cheap, I feel like. But like as you scale out and as there's more and more data, then it gets really, really expensive. And he mentions here that like it's 50 million a day. If you're trying to store something that has like YouTube views that people get, and if there's like 10 million views per second of people watching YouTube videos, then it would be $50 million a day. I don't know. Like this could be fine too, because 10 million views a second is actually a lot. So I'm not sure how much that is worth. 10 million views a day. If you took off RPMs, that'd be about what, 1, 2, 3, 4, 5, like $10,000 a second. $10,000 every second. Then you do 10,000 times 10 to the 5th. 10 to the 5th times 10 to the 5th, 10 to the 10th. A million? No. 10 to the 6 is million. That's a billion. That's gotta be a billion a day, honestly. if this is ads, I'm thinking about the RPMs or whatever, but I think this translates to $1 billion every day. I don't know, but it could totally be expected that this is actually fine. Like it scales out. You don't actually, the cost of your business doesn't fail at $50 million a day or whatever. 50 mil a day is cheap AF at that rate. Yeah, I don't know actually. It's probably not. I'm probably wrong about that math that I just did, but whatever. And there's DynamoDB accelerator, so it even comes with a memory cache. I didn't know this. There's a built-in in-memory cache, so you don't even need to use Redis if you're using Dynamo. You can probably even bring that up in an interview, although I don't think they'd probably be happy about it. But and then they even have change data captures through DynamoDB streams. Oh my god, so nice, nice. It's 86. There's 86k seconds in a day. So yeah, yeah. Loading limitations. You get vendor lock-in. Complex queries are tough. Really hard with NoSQL, and then database modeling is super weird, but super cost efficient, I think. I feel like it is very cost efficient, but it can get expensive with high work volumes. So you need hundreds of thousands of writes, then it may outweigh the benefit. I don't know. I think this is like a pretty good write-up, and really covers a lot. Like this is probably all you, I mean, definitely is all you need to know in a mid-level system design interview. Like you could pass without knowing any of this stuff for sure. But it's just interesting knowing like the benefits that it has. Pricing, I don't think is as important, but the knowing the benefits, knowing like how it's actually built, knowing generally how you can use it. I got actually quizzed a little bit about it in my Amazon interview. They kind of expected me to know the words basically for this, so like table, items, and attributes. And then I didn't even know that it had its own like query language basically, or query syntax or whatever. But yeah, I've been using the site as well. It's pretty solid. Yeah, it's pretty solid. It's a lot of good information in here. And then I went over to this Elasticsearch one, DynamoDB, and yeah, maybe we'll go over Kafka and Cassandra. I read these alone, and they were pretty cool. I don't think I read the Kafka one actually, but yeah, it's good stuff. Good stuff. Would recommend. 10 out of 10. Not actually 10 out of 10. There's some of this stuff is like these things aren't that deep, but yeah. Anyways, I think that's it. So we'll call it here. What level are you aiming for? E4, mid-level, mid-level.